Good afternoon. My name is Cheyenne Smeaton, and we conducted the gummy bear experiment this week, and here is my presentation on the gummy bear experiment. The experiment materials that we needed was gummy bears. You need at least 3 gummy bears, one for the salt water, one for the tap water, and one for comparison. You need salt. Normal table salt will work the best in this situation. Tap water, and 2 clear containers. In this case, I just used 2 food storage containers that I had, little tiny ones that I could fill up with some water, some plain tap water, and some that I could fill up with water and salt. And then I placed the 2 gummy bears. I placed one in one mixture and then another gummy bear in the other mixture. I let them sit for 6 to 12 hours. Typically when I put them in the morning, it was around 10 o'clock a.m., and then I let them sit for about until 6 o'clock at night. The steps that were needed was, like I stated, soak a gummy bear in tap water for 6 to 10 hours, which is what I did from the 10 o'clock in the morning to about 6 o'clock at night. And then soak a different gummy bear in the saltwater solution for the same amount of time. I did put both the gummy bears in each solution at the same time. Then you want to take both gummy bears out and compare them to the original gummy bear size. So here's a little diagram that I did find online, just stating I thought this was a good visual that everybody could see. And in 1 cup there's the distilled water in the gummy bear. The gummy bear has double the size, maybe even triple. In the salt water you can see that it shrinks compared to the original size. What happened? The gummy bears are semi-permeable. Water will be entering and leaving the membrane. Since the water will be entering and leaving the membrane, that means it's semi-permeable. The water should leave gummy bears when placed in salt water, meaning that is the reason why the gummy bear is shrinking in the salt water mixture. When you place the gummy bear in the salt water, it is an isotonic solution. And this pretty much means that the gummy bear is absorbing all of that salt and it's not allowing room for the water to go in so that it shrinks. Tap water will make the gummy bear swell, and that is a hypotonic solution. The tap water, due to osmosis, will allow the water to flow into the candy's membrane. In this case, it was the gummy bears. And when it flows into the membrane, it will increase the volume and mass, which is why the gummy bear doubles, sometimes triples in size. We can see this example great in the picture that is provided in the next slide, which is right here. This is the evidence of my gummy bears. On the right hand side you can see that gummy bear was in the water and the tap, which was the tap water that I used, and you can see that it was very delicate when I picked it up out of the container, so I had to be very careful not to break it when I put it on the plate, which I did not realize at first. I figured it would have been a little bit more solid, but compared to the original size, it's about doubled in size. And then you can see up in the left corner the gummy bear that was in the salt water solution. This one is shrunken, and you can see compared to the original size that clearly this has lost volume and mass compared to when it was the original size. And with all 3 of these gummy bears, this was the evidence and the picture that I chose for this presentation to show that I did this experiment at home. And altogether you can tell that the water and only the gummy bear in the tap water was a hypotonic solution, whereas the saltwater solution with the gummy bear was an isotonic solution. On the last slide, this is some of the works cited that I used. I did watch one of the YouTube videos from the learning materials that was provided this week, as well as doing my own research. And I hope everybody enjoyed the presentation and had a great week. Thank you, and have a great rest of your week.